In this example, we are asked to perform a couple of polynomial long divisions. So let's start with the first one in part A, where we're asked to divide 2x cubed minus x plus 1 by x squared plus x plus 1. So let's set this up with our divisor, x squared plus x plus 1, and we're going to divide this into 2x cubed, and I'm going to put a placeholder here. So notice that the first polynomial is missing a x squared term, and when we're going to be lining up and subtracting terms in this process of long division, it's really important that we line up terms with the same powers of x. So I'm going to put that 0x squared in as a placeholder, and that's a really helpful hint to help us avoid any mistakes in the future doing this problem. So here we go. And so the first thing that I can do is I want to cancel the leading term 2x cubed over here. So what should I multiply the leading term of the divisor by to match the leading term 2x cubed? That's the first question we want to ask. So what I can do is multiply the divisor by 2x. And that's going to match these terms up. So I'm going to put this on top over here. And now let's compute the product. And we're going to subtract what we get when I multiply 2x times the divisor, which is x squared plus x plus 1. And so when I calculate this product, I get 2x cubed plus 2x squared plus 2x. So now I want to subtract this from the polynomial. And so if I subtract this, that means I've got minus 2x cubed minus 2x squared. And you see that's why we have this placeholder over here. And then we subtract the last term, and we get a minus 2x. And so now we're going to group like terms. And at this point, we better get the leading terms to cancel out. So we have these terms cancel, and what's left is minus 2x squared minus 3x plus 1. And now we ask, what do we need to multiply the divisor by in order to cancel the remaining polynomial? The leading term here is minus 2x squared, and the leading term here is x squared. So now we're going to multiply the divisor by minus 2. And let me put that up on top here. And this means what we need to do is subtract minus 2 times the divisor, which is x squared plus x plus 1. So multiplying this out, we get minus 2x squared minus 2x minus 2. And we're going to subtract this. So that means I'm going to be adding 2x squared plus 2x plus 2. Okay, and so when I subtract this, it's the same thing as adding minus 1 times this. And so that's why we get all these sign changes here. And now we subtract, and we're going to group like terms. And so now we get a cancellation of the leading terms, which again, always had better happen. And the minus 3x plus 2x gives me minus x, and the plus 1 plus 2 gives me plus 3. And now, if we take a look, we've got a remaining polynomial, which is a leading term of minus x, and our divisor has a leading term of x squared. So there's nothing that I can multiply this by to cancel off the minus x. So once the degree of the remainder is less than the degree of the divisor, this process is done. And so what we see is that this x squared plus x plus 1 doesn't cleanly divide into the polynomial 2x cubed minus x plus 1. We have a remainder minus x plus 3. So what we write is when we take 2x cubed minus x plus 1 and divide this by x squared plus x plus 1, we get 2x squared minus 2 with a remainder of minus x plus 3. Okay, so just like dividing numbers, we don't always, not all polynomials divide others perfectly. We oftentimes wind up with a remainder, and that remainder better have a degree which is less than the degree of our divisor. Let's now take a look at the next one in part B. In part B, we're going to divide 4x to the fourth minus x squared plus 2x minus 23. We're going to divide that by x squared minus 1. And so notice we're missing an x cubed term over here. And so we want to be sure we include a placeholder for the x cubed term when we set up our division. So we have the following: x squared minus 1, which we are dividing into 4x to the fourth plus 0x cubed, putting our placeholder for that term, minus x squared plus 2x minus 23. And we start by saying, what do I need to multiply the leading term of the divisor by in order to match and cancel the leading term of the polynomial? And so if this is 4x to the fourth, I need to multiply this by 4x squared. So we're going to multiply by 4x squared first. And so when I do that, I get 4x squared times the divisor, which is x squared minus 1. And this gives us 4x to the fourth minus 4x squared. And so now I'm going to subtract this underneath the division sign. So this means I'm going to subtract minus 4x to the fourth. And when I subtract minus 4x cubed squared, that's the same thing as adding 4x squared. And we have a placeholder here as well for the x cubed term. And now, adding these together, we get a cancellation of the leading terms. We have no x cubed term. And now this gives me 3x squared. And let's bring down all of the remaining terms. And so now I look at the remaining polynomial, which has a leading term of 3x squared. My divisor has a leading term of x squared. So for these to match, I need to multiply the divisor by 3. And so when I multiply the divisor by 3, we wind up with 3x squared minus 3. And now we're going to subtract this. So that would give me minus 3x squared. I have no x term, and when I subtract the minus 3, that is the same as adding 3. And now I see how my terms cancel out. So these cancel, again, which always should happen. My 2x comes down, and this gives me minus 20. And so now the degree of the remaining polynomial is less than the degree of the divisor, and so we're done. This polynomial, x squared minus 1, doesn't divide cleanly into the polynomial 4x to the fourth minus x squared plus 2x minus 23. We have a remainder over here, just like we did in part A. So what we would say is that when we take 4x to the fourth minus x squared plus 2x minus 23 and divide this by x squared minus 1, we wound up with 4x squared plus 3, and we had a remainder of 2x minus 20.